In this video, the objective is to calculate quantitative properties of a satellite or of a planet in circular orbit around another planet. More specifically, we'll try to find a relationship that we'll use in order to calculate the speed of a planet or a satellite and examine the factors that this speed depends on. We can start with examining the motion of a planet around its star, for example, the motion of the Earth around the Sun. We know that between any two objects there is a gravitational attraction, so between the Earth and the Sun there is a force of gravity, which can be expressed from Newton's law of universal gravitation with the rule capital G, mass of the Sun times mass of the planet, divided by their distance to the power of 2. We also know that for circular motion there is a centripetal force that is equal to the mass of the revolving object, in this case it is the planet, times the speed square divided by the orbital radius. By equating the two expressions, we can get a formula for the velocity of the moving object, in this case it is the planet, so the velocity of the planet is root capital G times mass of the Sun divided by the orbital radius of the planet. In a similar way, we get a rule for the velocity of a satellite as it revolves around the planet. The velocity of the satellite is root capital G times mass of the planet divided by the orbital radius of the satellite. We can conclude by mentioning that for both cases, for the velocity of the planet and the velocity of a satellite, the speed is inversely proportional to the square root of the orbital radius, which is the distance between the two objects. Finally, the velocity does not depend on the moving object. The velocity of a planet only depends on the mass of the star, and the speed of the satellite only depends on the mass of the planet. We can finish with an application. You can try to find the velocity of a spy satellite that is launched in an altitude of 700 kilometers above the surface of the Earth. You are given the value of capital G, the value of the mass of the Earth, the Earth's radius plus the satellite altitude. Please be a little bit careful that the orbital radius is the distance between the center of the Earth and the satellite. You can pause this frame and proceed with your calculations. And when you're done, you will find that the velocity of the satellite is approximately 7,500 meters per second. Thank you for watching.